Hello everyone, I've got this lovely kinematics question here for you. Let's get started. We'll pull the data out of it first of all. So if we read it, we've got a racing car enters the final 600 meters at 35 meters per second and finishes in 12 seconds. What's its speed at the finish? So let's pull those numbers out. We've got words and numbers together. That's never fun in any maths questions. So we'll start off and write all the data down. What do I have? Well, first thing I've got here is I've got my distance. The symbol for distance is S. Should be D really, shouldn't it? But that got taken up by something else. That's 600 meters. Our next bit of data is this here. Now, if we reread the question, a racing car enters the final 600 meters at 35 meters per second. So if we assume that we have a racing lap, that'll do. And there's our car. That's the red here. And that's coming round the corner. And as it gets to the final straight, that's where it's going at a speed of 35 meters per second. So that would be here. And then it's going to finish in 12 seconds. So what we can assume is constant acceleration, because it's going to come round this corner at a certain speed. Then as soon as it hits this final 600 meters, which we would say would be from here to here, it's going to go straight, and it's going to be going as fast as possible because it's aiming for the finish, and so it's going to speed up. So we're going to look at the speed it was when it came round this corner as its initial velocity. The symbol we use in the UK is a U. Now that was 35 meters per second. Now you may use a V with an I, initial velocity, or you may use a V with an O. Go ahead and use whatever you're used to. You'll hear from my accent, I'm from the UK, and so we do things differently, obviously, in all different countries, but I will cover any differences that I know are significant. Then our next bit of data we've got is our time, and that is 12 seconds. We're not going to worry about acceleration because we can assume it's constant, like we said, but the last thing we do need is what they're asking us for, and that is its speed at the finish. So that would be its final velocity, and that symbol is the V. And then from this lot here, we've got to decide which physics equation we're going to be using. And we want one that connects distance, also known as displacement, which is S, initial velocity, time, and then final velocity. And that would be S equals a half multiplied by the initial velocity plus the final velocity multiplied by time. Now this formula is actually the formula for the area of a trapezium, and I'll go into that at the end of the video, why we use this formula. It's linked to velocity time graphs. But for now, let's work out what the question's asking us. I'll get rid of this for us. So we'll bring the question up here and we'll pop our numbers in. So what do we have? Well, we have S, which is our distance, that's 600, equals a half multiplied by our initial velocity, that was 35, plus the velocity we don't know, all multiplied by 12. And then we just go ahead and rearrange this equation. So firstly, let's get rid of this 12, and we divide both sides by 12 to do that. That's 50. And then we want to get rid of the half. And to do that, we have to multiply both sides by 2. So we get 100 equals 35 plus V, and that's quite nice. We're just going to subtract the 35 from both sides. So we end up with V equals 65, and its velocity, meters per second. And there's your answer. I have another one for you. This one is very similar. We have a runner increases speed from 5 meters per second to 7.5 meters per second over the last 100 meters. So how long does she take? This one we're being asked for time. So like before, let's pull the data out, and we have first bit, we've got initial velocity, that was a U, and final velocity is a V. So U equals 5. meters per second. And then we have V equals 7.5 meters per second. We've got our distance, which is here, that's 100 meters. And then lastly, we want time. How long does she take? And we don't have that. So T equals, good old question mark there. Same equation. Might as well bring our equation up here. This is where we're going to be working from. And that was S equals a half U plus V multiplied by T. And put our values in. S is 100 equals a half. U is 5. V is 7.5. Close the bracket, multiply that by T. We add the bracket, so we have 100 equals, should do each stage, so 5 plus 7.5, that's going to give us 12.5 multiplied by T, so a half of 12.5, 6.25 by T. Then we divide by the 6.25, and that's a nice number, that's 16, so time equals 16 seconds, and underline that. Now, as I said, I will explain this equation, and why it's the same formula, finding the area of a trapezium. So if you look in any maths book, the area of a trapezium is this. It's the area of the average of the parallel sides, A plus B, multiplied by the height. Trapezium is a quadrilateral that has at least one pair of parallel lines. So that's the classic trapezium you will see, where you have this side and this side, they're parallel. So there's A, there's B, and then we have the height. And the area, this space all in here, that will follow that formula. Now you can see how similar this is to this one. And that is because this comes from a velocity time graph. And a velocity time graph looks like this. And when you assume constant acceleration, as our questions have, you'll be working with an initial velocity and a final velocity and time. And to find the area, the graph would look like this. So you'll start with an initial velocity here. Now that would be u. And then because you're accelerating at a constant rate, you would have a slope, a positive gradient. And it would stop, say, about here. That point there, that's going to be TV, because T is your x-axis, and then V is going to be on your y-axis, the velocity. Then if you draw a line down to the time axis and you're looking for displacement, you're looking for the distance, and that's this area under here. And because this on its side, slightly different than this one, but we have a line here and a line here. So there's your parallel lines. And then this distance here is your height. So this in effect is A and B. And then your height is your time, T. Now I will do a few more videos on kinematics. There's quite a few other equations to be working through. So keep an eye. Go ahead and hit subscribe, obviously, to be notified of those future videos. And if there's any in particular you'd like me to record, do pop a note in the comments below. Thank you ever so much, and I'll see you in the next one. Take care. Bye-bye.